Good evening, ladies and gentlemen. Today I want to express something interesting that just happened. I'm developing skeletal metrics at the moment, and I'm developing it for Blender because Blender allows for more versatility in using different codes as compared to SketchUp, where I did hit a lot of boundaries I was not expecting, and so Blender seems to be a better way to explore this code. So here's a shape that I have created through this methodology of skeletal metrics. This precisely was done with this file. This one is called the skeletal webbing. Now it's still under development. There's a lot I have to clarify about this, but I want to show what it does. So here's the shape that I made. You can see here that it looks kind of like a roll cage for a car. There's some structural qualities to this. It seems like these kind of vector would distribute weight effectively. It can be used for architecture as well. So if you can think of this as the size of a house, where maybe one of the sides here would be large enough for a car. So here, let's change the shader. So you can see a house designed the same fashion. It could be kind of a cool design. But the point is, it's the generation system to achieve this. Now I do have to work on the quality of all this, how to make it better and more intelligent, and to relate these points. But the essence of it was to use a grid like this that's called the skeletal prism, which is basically a group of cubes that is organized in a specific fashion in space. And by the position of each cube, I can then create different patterns in the cube in order to generate this geometry. Let's start from the beginning. Let's delete everything. So I have here under the Create tab the Create Prism, which is an add-on that I made for SketchUp. And I can create my prism like this, and then I can edit its properties. So if I want to have it done out of a rectangle, I can go like this. And you can see that the grid changes accordingly. I can manipulate all three sides. And so I can measure different proportion. So I can also change the prism width, so maybe I want 10 of those. And now I have this malleable grid system that I can utilize and create different origin points in space. So let's say I like this one, so I'm going to use a few different cubes. So I'm going to make a selection here of different cubes. Now I am working on a notation system in order to codify selecting objects like this. So I'm continuing the selection. See, now you can see that it might become difficult to select certain cubes. See, if I want to select exactly the third one from there, it can become confusing. So I need some methodology in order to be able to select the precise cubes that I wish. But you'll see just in a minute how effective this is. Ah, shoot. No. There you go. Okay. So let's say I'm happy with my selection. These are the prism that I want to use. So what's going to happen is that these cubes are going to serve as three-dimensional vectors, or anchor for those vectors, or these vertices. It's basically a grid that's utilized in order to create different location that I can use to generate automated geometry. And so this function is called skeletal webbing. And so if I go here, skeletal webbing, now what we get is a little bit odd, but you'll see just in a minute. I'll change for this view. You can see all the geometry. I understand that this is a lot of overlapping geometry, and so there's a problem in there. But it's the idea of relating points in space, and how can you create those so that it is useful, right? So the next up in my list is to create a function that will enable the intelligent selection of points in space so that I can replicate objects that exist. So for instance, I could use a mold of a bucket seat, and by processing it through a skeletal prism, I will be able to recreate its shape in a way that I can manipulate. It is about the intersection of organic shapes and skeletal prisms. You can see here how, like, the beauty of the skeletal prism, its geometric resonance. And so I can create things like this. I can relate objects through space, and I can do so intelligently. Now these points here, they have a value or an index value. So the position of each cubes here is, or rectangular prism, is recorded in their names. So if I go up here, you can see that there's an index for every cube, and I can select them according to that index. And you can see here that the way it is written is how to say, not cohesive, but it is made intelligently. And so if I want to select this cube, by looking at it, I can count that the x value of this origin point, or the positive origin, is 0 x, and then I have this is a third y unit, and this is the 0 value z. So that would be 0 to 0 for x, y, and z. And I go at the appendix, and the name of that cube is complemented by the attribute of x, y, and then z. So each object here can be selected according to its index. So there's a vast amount of index. I should create a grid so that I can represent more of those, or more effectively perhaps. Now I'm developing this so that these objects are grouped more intelligently, so that I can have linear projections and planar groups. Therefore I could have a more intelligent hierarchical system to organize this cube. Not only this, but it also helps to improve other functions in alleviating the workflow. If I can analyze these different skeletal prisms by using planes and projection lines instead of individual cubes, because you can see here that there is how many elements in here? I'm not sure how many objects there is. That was 10 by 5 by 5. So that's 500, is that it? There's 500 objects up here, but what if there was 10,000? You need a way to analyze through it quickly, so to make it effective. Because this is a scalable idea, meaning that it can be applied to any scale. I could be working on something that is microscopic alongside something that is macroscopic, because it is a it's a grid or a prism that enables you to understand the proportions of something better by dividing it into equal sizes, but not only in two-dimensional but three-dimensional space. This is beautiful. I'm going to do some more progress on it tomorrow. I think that's going to wrap it up for today. I just wanted to make this video to let you know about the progress that I'm doing, which is, I consider that to be quite beautiful. Anyways, you have a good night, and I'll see you another day.